because according to the CPU time we manage the number of processes. So, it selects which process should execute next and allocates CPU. It invokes very frequently, and this process, this type of jobs executed very fastly, and that makes our multitasking and multiprogramming very fast. And through these short time schedulers we realize that our input or output device is performing very efficiently and very fast, because that type of schedulers are the short term schedulers. So, another type of scheduler is medium term schedulers. Medium term scheduler swaps out processes temporarily and balance load for better throughput. Okay. So, medium term schedulers performing their processes after crossing a number of stages. Okay. They may swap in and swap out their partially executed processes. In ready queue, number of processes ready to execute, they are getting their CPU time. If they require any input output devices request, then it goes to the input output queue, otherwise it going to their this partially executed stage. That means in between, if any process interrupted, then partially executed processes going to store in this stage. Okay. So, this is a medium term scheduler, or this term scheduler happens at time sharing systems. So, there is number of processes, there is number of different type of processes. First is input output bound processes, that more spends time on input output. If a process spend their time on CPU, then process is known as CPU bound processes. And the right job mix, that that type of processes that have long term schedulers, and they are mixing of input output devices and CPU bound systems. That means the process spends more time on input output, that process is known as input output processes. The process or job spends their time on more CPU, that process is known as CPU process, CPU bound process system. If the job is mixed with input output request and CPU request, that known as a mixed job processes. Process creation, processes are created and deleted dynamically. Process which creates another process called parent process. The process is called a child process. Okay. Resources required when creating processes. So, if we are creating a process, the number of benefits it comes. Resource sharing, that means parent and children shares all resources. Children share subset of parent resources. Parent and children shares no resource. There is number of stages, number of options are comes while we are sharing our resources in between parent and child. Next is execution. Parent and child execute concurrently and simultaneously. Parent waits until child has terminated. Okay. There is some of circumstances comes. Address space, child processes duplicate of parent process, child process has a program loaded into it. So, process terminated after their completion, and process may terminated by exit command or deleted it. Output data from child to parent. Process resources are deallocated by the operating system. So, operating system manages or where allocate the process, whereas deleted or deallocate the processes from the memory. Parent may terminate execution of child process. Child has exceeded allocated resources. Task assigned to child is no longer required, then parent may terminate their process. Parent is exiting in that case where operating system does not allow child to continue. If operating system want that child does not continue, then it may terminate our child process. Then cooperating processes, that means where number of processes executed simultaneously, then cooperating processes occurs. The concurrent process executing in the operating system may be either independent process or cooperating process. That means one process require the input of another, and one another process require the output of one process. So that type of process is known as a cooperating processes. So where we are using cooperating processes in while we are sharing information, competition, speed up, modularity, convenience. So for modularity, convenience, we want to or we prefer the cooperating processes. So next function of operating system is memory management. Memory management is the technique used by operating system to allocate physical memory of finite capacity to multiple requesting processes. That means memory management allocate the physical memory to the different number of processes so that they are executing simultaneously and independently. So there is number of important aspects of memory multiplexing. First is controlled overlap. Process should not collide in physical memory. So that is the main headache of the memory management, so that they does not collide in another process memory. So or it always or ability to share memory when desired. So that collision is managed by the memory management. So second is protection. While they are sharing their memory and allocate the physical memory, protection is important so that each and every process executed simultaneously and independently without collision. So third is translation. Ability to translate accesses from one address space to a different one. That means virtual address to the physical address. When translation exists, processor uses virtual address, a physical memory uses physical addresses. So names and binding, that means we are converted our logical address into physical address. Firstly we adds into symbolic name, and symbolic name is a file name, program name, any printer name, and then symbolic name converted into logical name, that means job number, device number, process number. Then process ID or process number is converted into physical address, where the actual address is going to be stored and want to address or want to access the memory, allocated memory. Okay. Firstly we add the file name, the file name is converted into logical name, that logical name is converted into physical name. Physical name is actual address in memory where the data and file is stored. Then logical memory is converted into physical memory. The concept of logical address space that is bound to a separate physical addresses is central to proper memory management. And here logical address is also known as a virtual address, and logical address is generated by the CPU, whereas physical address is generated by the memory unit. And logical and physical addresses are the same in compile time and loading time, whereas logical and physical addresses different in execution time. Okay. At the time of compiler, logical address and physical address are same, but in execution time logical and physical address are different. Swapping. A process can be swapped temporarily out of memory to a backing store and then brought back into the memory for continued execution. Okay. So swapping means processes enter into the execution, and if they are getting any interrupt, then it swapped out from the memory and waiting for a memory allocation again. That means it comes and it comes out due to the interruption occur. Backing store means fast disk large enough to accommodate occupy of all memory images for all users, must provide direct access to these memory images. Roll out and roll in, that means the process is coming into and come out according to the scheduling algorithms. There is number of scheduling algorithms, according to that we getting a priority. Okay. Then a major part of swap time is transfer time. The total transfer time is directly proportional to the amount of memory swapped. So in this way a process is going to swap in and swap out. Operating system, there is two processes going to execute it. When one is going to execute it, then it process gets the CPU time, then that means it is swap in, and after getting the interrupt, then single process swap out. One is enter, another is out, that means one single process is activated. Okay, a single process gets the operating system time. One is executed, another is waiting for input output devices and CPU time. So continue allocation memories, main memory usually into two partitions. Okay, single partition allocation, reallocation register schemes used to protect user and processes from each other and from changing operating system code and data. Reallocation registers contain value of smaller physical addresses. Okay, each logical addresses must be less than the limited memory. This is reallocation registers. Reallocation register, CPU generates the logical address and then physical address is generated. Physical address is generated by adding base address and the logical address. Base address and logical address, summation of this is generates the physical address. That means physical address is equals to base address plus logical address. Then we are actually getting the address of a particular file in a memory. So fixed memory, where we are actually getting the particular job or particular partition into a memory space. So next is paging. A logical address space of a process can be non-continuous. A process is allocated physically memory wherever the latter is available, divides physical memory into a fixed size blocks called frames. That means a single physical memory is divided into number of blocks. That block is known as a frames, and different logical memory divided into small size, that blocks are known as pages. So in this way we are getting the paging from a physical memory. CPU generates a logical address, then logical address is converted into a physical address by adding the base address, then actually we getting the physical address and then point to the physical address and getting back to the particular file on that particular address. This is an example of paging. Logical is converted into physical and there this number of files is occupied. Then again is a segmentation. Memory system scheme that supports user view of memory. A program is a collection of segments. A segment is a unit, logical unit such as main program, procedures, functions, logical variables, global variables, common, block, stack, symbols, array. That small logical units are known as a segmentations, and it protects each entity independently, and it allocates or allow each process to grow independently, and it shares each segments independently. In this typological view of segmentations, there is a user view, another is physical memory where the segment is stored. Now overall summary of our lecture, we have learned about the operating system definition. So in brief, operating system is a control program that acts as a intermediator between user and hardware. Next we learn the process definition. Process is a task or is an instance of a program that across the 5 stages. First is new, ready stage, running, waiting and termination. Then schedulers long term schedulers, short term schedulers, medium term schedulers. Long term scheduler is known as CPU schedulers, job schedulers. Short time schedulers is known as a CPU schedulers. Next we are going to learn the definition of memory management. Okay. So swapping a process can be swapped temporarily out of memory to backing resource and then brought back into memory for continue execution. That means while a process is going to execute it, a single process is swap in and swap out. Paging, different logical addresses converted into physical address. There are small unit of small blocks of physical address or frames is known as a frame. Okay. So next is segmentation. Segmentation is a logical unit such as the main program, procedures, local variables, global variables, and common blocks. Okay. So segmentation is a small logical units. Either it will be a small procedures, function local variables, and global variables. So overall we have discussed operating system definition, process, and there are number of process stages, there are process schedulers. Process schedulers is of three types: logical term, short term, medium term. Okay, according to the scheduler, the process is going to execute it. The process may be created or terminated. Process is going to created by a command, fork command. Process and child process. Child process is generated from the parent process, and child process we can say that it's a small logical units. Okay. So next is memory management. In memory management we discuss paging, segmentation, how the logical address is converted to the physical address. Okay. So logical address is generated by the CPU and physical address is generated by the memory. Okay. Logic and CPU processes. So in memory management there is swapping, paging, and segmentation we have discussed it. Okay. So there is number of processes comes in memory and processes. Thank you.